Okay, we're dealing with section 1.3, day 1. Our objectives today are to calculate measures of center, particularly the mean and the median, calculate and interpret measures of spread, the range, and the IQR, choose the most appropriate measure of center and spread in a given setting, and identify outliers using the 1.5 times IQR rule, make and interpret box plots of quantitative data. Okay, let's start with the mean. We know what the mean is. Add the numbers up, divide by how many numbers there are. We know that that's the mean. A lot of times you'll see it referred to as X bar. That's what this is, X bar. And it equals the sum of all the observations. That's what this sigma means, sum of the observations divided by how many there are. So that's two ways you'll see that. The median, the middle number, when the numbers are organized from smallest to biggest. You find the number in the middle. If there are two middle numbers, then you average them. The mode is the observation that appears the mode. Mode most, mode most. Those are not new to us. I know that. Okay. All right. Comparing the mean and the median. This can become an important thing because it'll help us choose which one would be better in a particular setting. In a roughly symmetric distribution, the mean and the median are very close. If it's a perfectly symmetric distribution, then the mean and the median are exactly the same, as well as the mode. The mean, median, and mode are all exactly the same if it's a perfectly symmetric distribution, which of course doesn't happen all that often. But the more skewed a distribution is, the more the mean is affected. Okay? And if the distribution is skewed to the left, such as the picture here, then the mean is further out in the long tail. So the median would be maybe here. The mean is going to be closer to that long tail. The mean is more affected by the tail than the median is. Okay? Measures of spread, the range. The range is just the highest observation minus the lowest observation. High minus low, max minus min, however you want to say it. That is the range. And it's a very simple, simplistic measure of spread, but it is one that works. The IQR, the interquartile range, IQR. Q3 minus Q1, that'll mean more to us in a minute when we talk about the quartiles. Okay. All right, how to calculate Q1, the lower quartile, Q3, and the interquartile range. Here we go right here. We have what's called a 5-number summary. Okay, a 5-number summary is pieces of data that tell us a lot about the data. So we usually give the lowest observation, okay, the highest observation, those two, okay, the median, so the middle number when you line them up from smallest to biggest, Q1, the lower quartile, quartile 1, there's several names for it, is the median of the bottom half of the numbers. It's the median of the bottom half of the numbers. Q3, the upper quartile, or quartile 3, is the median of the upper half. Sometimes you might hear the median referred to as Q2, the second quartile, okay, just so you're aware. All right, identifying outliers using the 1.5 times IQR rule. An observation is an outlier if it falls more than 1.5 times IQR above Q3 or 1.5 times IQR below Q1. So if we take the interquartile range, whatever it is, Q3 minus Q1, multiply it by 1.5. If we go above Q3 by more than that, it's an outlier. If we go below Q1 by more than that, then it's an outlier. A box plot. You've also heard it referred to as a box and whiskers plot. It looks like this. Okay? It's just a graph of the 5-number summary. So if we have a 5-number summary here, the minimum, the maximum, the lower quartile, the median, and the upper quartile, or Q1, median, Q3, they all get bars. And the Q1 to Q3 is made into a rectangle like this, and then we connect to the outside of the rectangle with the tails. Okay? And this would be a graph of the 5-number summary. Now, half of the data is in between Q1 and Q3. That's 50% of the data is in that box. 25% of the data is down here, and 25% of the data up here. Now, we can talk about shape, we can talk about center, we can talk about spread when it comes to box plots. So in this one, it's fairly symmetric. The median's here. It's not perfectly symmetric, but it is fairly symmetric when you look at from the median down, the median up. it's close to the same. It's as I've said before in statistics, we don't usually deal in what things are perfect. Okay. All right. Now let's look at this example. What we're looking at here is it's the amount of fat grams in 9 different McDonald's fish and chicken sandwiches, okay, along with a stem plot that they made. And you can see the filet of fish has 19 grams. You can see that's right here. They made a split stem for 1 and 2, and they didn't need it for 3 and 0, so they didn't use the split stem for those. Okay. And our first says find the mean amount of fat for the fish and chicken sandwiches. Well, add them all up. So we add these up, these numbers up, 19 and 16 plus 22 plus 33 grams of fat, 27, 9, 20, 14, and 19. Add them up and divide by 9, and we get 19.88. So that would be the median. That would be the mean grams of fat. That would be the mean grams of fat when we add them all up and divide by 9. Okay. Now the median we can get from our stem and leaf plot here, because we take 1 off the top, 1 off the bottom, 1 off the top, 1 off the bottom. Okay. Or actually it's 1 off the bottom, 1 off the top, 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 and what's left is this 9, which represents 19. So 19 grams of fat is the median grams of fat in those chicken sandwiches. And the mode, there's only one number that's repeated, and that's 19. So 19 is also the mode. So we found all 3 measures of center. Okay. It says the premium chicken, question B, the premium chicken crispy club sandwich is a potential outlier. How much does this one sandwich increase the mean? Well, if we want to know that, what we'd have to do is calculate the mean without that sandwich. So we remove, up here we had 33 in there. We're going to remove the 33, and we're going to repeat the process of calculating the mean. And the mean we got was 18.25 when we add all up, and now we divide by 8 instead of by 9 because we eliminated 1. So 18.25, 19.88, that one sandwich increased the mean by 1.63 grams of fat. That's a lot. Okay. Now, it's another example using this side McDonald's beef sandwiches. Okay, here are the data for the amount of fat grams for McDonald's beef sandwiches. This time we're going to enter the data into our calculator using stat and then number 1, edit. So I'm going to do that right here. I'm going to hit, I will hit, clear it out, hit stat. The stat button is right here, is the stat button. Stat, and number 1 is edit. And then we start entering them in. 29, 12, 24, 23, 43, 9, 19, 26, 29, 31, 27, and 26. Okay. Well, we get out of there. What we want to do now is we want to calculate, okay, make a stem plot, which we will do in a minute, but really we already know how to do that, so I will leave that to you. But we want to make the 5-number summary and create a box plot. We're going to have the calculator do both. So let's do the 5-number summary first. Here's what we do. Right here, it is stat, and then we're going to go over to calc, and then we're going to hit number 1, which says 1 var stats. 1 var stats. Okay? So let's do that here. So stat, over to calc, 1 var stats, and it asks me for a list. Well, I already used list 1, so I don't have to change that. And there's no frequency list, we don't use that, and just hit calculate. And now right here on this screen, one of our stats has a lot of information. Right here, X bar, there's the mean. That's the average grams of fat in these beef sandwiches. These two are the standard deviation, which we'll learn about later. And then n equals 12, and you'll see an arrow pointing down, which means we can scroll down, hit the down arrow, and keep going. And notice here is our 5-number summary. The minimum is 9. Q1, 21. The median is 26. The third quartile is 29, and the maximum is 43. So I took those down here. I have them down. We're going to graph it. You could graph it by hand, but I'm going to show you how to graph it with the calculator. So here's what we do. Graph it with the calculator. The instructions are right here. Second y equals. So let's get out of here. Second y equals, and it comes up with this menu. And we have to turn the stat plots on. So number one, we're going to turn it on. And then we're going to go here, and we have to move over to, now both of these are box plots. This one is a box plot, and the dots indicate that it will exclude some outliers. If something's an outlier, we'll exclude it and use something else as the maximum for that. Or this one is standard, well, it would not exclude any box plots. So I hit that one. X list is L1. I don't need to do anything with that. Now once I've set it up, I need to go zoom, and number 9 is zoom stat. So it looks at the numbers I put into when I inputted those fat grams, and then it creates a window that fits that. So zoom. I'll scroll down, but you could also just hit number 9. You could just hit zoom 9 and zoom stat, and there is our box plot. And the other graph on this, something must be in y equals, and we just ignore that. Okay, we just ignore that. Now we can trace it, and there is the median, 26, says right down here. We can move Q1 minimum, we can move up to Q3 and maximum. Okay, and then we draw that on our paper, and we might discuss, in this case, this one, when we did it before, it took 43 as an outlier. This one we did it without the outlier situation. This one we decided 43 was an outlier. We did it with the other graph, and both ways are valid. We'll talk about when to use one or the other. Okay. And the last one you can do for yourself, do it in the same fashion.